So in this section, we are going to learn about the number form. So let me present my screen first. So first of all, we will be creating an empty project in Spark AI. We will be doing a simple project in split screen so that you guys can understand what is number form easily. So I'm going to create a blank project. And go to the workspace and clicking on the show or hide this document structure. So this is the default in the pipeline. So when we disconnect this path, it is the no signal. So we need to have a connection to this pipeline, to the device pipeline. So the device path contains of screen size, scale, and the three perspective, three area instance. So what is the scene of the main important thing in the scene render path is this two terms, the background and the scene object. So what does the background mean is what does it should be rendered in the background. So it is termed as the background and the scene object. What are the scene objects and which child object should be rendered. So this is termed as the scene object. So in order to do our split screen effect, we need two game objects. I will be creating that. I am going to name it as a let's try. First of all, let me create a plane. So now you can see the plane is visible in the game view. But when I drag and drop the left hand side object, when I connect this left side object to the scene object, it won't get visible. It is because the plane object that we created is not inside the left side object. So the objects that are inside the left side object will only be getting rendered. So what is the device? So say for example, the objects that are in that device will get rendered. The camera is in the child of the device and the focal distance and so on. So these are the ambient light, direction lights, the left side plane, the plane zero, these are all under the child of the device zero object. So that's why the plane gets rendered. So what we done here is we just break the connection of the device object to scene object and we assign the left side object to the scene object. So the object inside the left side objects will only get rendered. In order to our plane to get visible, we can put the plane inside the left side object. So now you can see the left side plane is getting visible. Now we can assign a material to it. I'm going to name it as plane mat 1 or 0 and change the shade type to black and make the color to red. So one more thing we need to notice here is the lighting won't appreciable to the left side object. Now when I switch the shader type from black to standard, the shader is getting rendered in black. This is because no lighting is occurred in the scene. Because you can see the directional light and the ambient lights are outside of the left side object. So this is why the left side object, the plane does not get affected by the light. So what we need to do is we can copy and sorry we can move and put it on the inside the left side object. So now you can see the light is getting affected by the plane. So this is how the scene object is work. So the background image is camera. When we cut it off, the camera image does not work. we can assign any texture to it to consider this as a background. Say, for example, I'm just importing my left PNG and assigning it. Okay, you can see the color is getting changed. So this is what the background texture is behind us. Now let me assign back to this one. So now we are going to create a split screen effect. So I just created a left side object. I'm going to make the share size from standard to flat. We don't need lighting. And I'm going to create it as a null object. I'm going to name it as a right side. So inside the right side object, I'm going to create a plane and we'll be naming as a right side plane. Something. Right side plane. And let's create a new material. Change the shape to flat and make the color to blue. So I'm just now moving my thing a little bit so that you guys can see. Now I'm drag and dropping the right side object to the patch editor. So now when we assign the object, right side object to the scene object, you can see the blue object is getting rendered, the red object is not getting rendered. This is because of the right side plane is not inside the left side object. So our requirement is a split screen effect. So what we need to do is we need to create the same render path like this, same render path, and just drag and drop the object. And we are going to use the same background texture. For the split screen effect, we need to add a next patch and then an add patch. Let me explain you this way. So in order this to work, I have created the two pictures in Photoshop. The namings are left and the right. So you can see here the off of the image we have the white color and off of the image is transparent. And in the right texture, the first half is transparent and the second half is white. So what we need to assign is we just need to drag and drop the left side image into the patch editor and we need to assign the alpha to here and the gender target to the next alpha. We need to do the same thing for this here too. So now what you have to do is to add these two mix patches and the final output needs to be get connected by the device. So now, so first of all, we can check the output and let me explain you in a brief way. Now you can see when I move the blue plane move towards my opposite screen, the plane is getting hidden. The plane does not show in the game view, user's view. It's the same for the left side plane. When I move the left side plane towards the left, it is showing. When I cross towards the half of the screen, the red plane is hiding. So this is the split screen method that they use for creating a cooking woman versus doctor, some something like that. You can use this method to create a different different filters like a boy with a half boy, half woman, like that. So this is the base thing of this effect. So let me explain you the effect, what how it's working. So we are creating a mix patch, and then in the alpha texture, we just doing the assigning the left texture alpha, and then for the next texture, we are assigning the scene render class texture. If we disconnect this texture and assign the render image, you can see now our red image is working. So we can consider this as a okay, off screen. So let me consider this first and then cancel. So now you can see the left image. You can see the left image, the half of the image is white and the half of the image is transparent. So likewise, you can see the screen also. The half of the screen is brown and the half of the screen is transparent. So this is how we are doing in the mix patch, and we are connecting to the device output. So likewise, you can see in the right picture. Let me connect my device output to the right. So now you can see like the right texture. So the first half of the image is transparent. Likewise, you can see in the user's input, the first half of the image is transparent. And the next, you can see the next half is it's a white image. And you can see the next half is getting rendered. So this is how the split screen effects work. We can do the split screen. You can create these two textures in Photoshop or Photoshop or some other site. So now what we are doing is we are keeping this off of the screen and this off of the screen, and we are adding both of these pixels by using the add patch. So the first of the left will get added and the second of the right also will be getting added. So these two forms will be combined together and then will forming a picture. So this is how the split screen effects work. So and that's it for the split screen effect. Okay. So do you guys have any doubt on this split screen? So I hope everyone is now. Okay, let me move to the next effort. We will be focusing next to the towards the freeze frame. I will be first saving this project. I'm going to create a new project. So in this project, we will be looking out to the freeze frame. So how will be freezing a frame? So first of all, we will be creating canvas and then a rectangle. So likewise, in order to use the freeze frame, we need a mix pack and then a shader under pack. And a delay frame. So I'm going to make a receiver. So now I will be explaining one more one. Okay, let me explain you the mixed batch. What does the mixed batch mean? So if the value is zero, so so the mixed batch first object will get shown. You can see here the value is zero. When the value is one, the mixed object, the second input gets shown. You can see the value is one. When I change the value to five, you can see the value is five. When I change the value to 0.5, the value is 2.5. So it's because the 5 divided by 2 like this. Like it's the half percentage of this value. From 0 to 5, the half percentage is 2.5. So this is how the mixed batch is getting working. So like this. First of all, we are assigning the camera texture. The camera texture is going to the mixed batch. And then we are outputting the shaded type. Okay, so why we are using the shader underpass? So we cannot directly assign this type to here. You can see it's not connecting between the two dots. So what does the shader underpass does? It inputs the shaders and then converts it to a texture. So in order to use the delay frame, we need a texture. So that's why we are using the shader underpass. The shader underpass converts the shader element and then converted it to a texture. You can preview it by just tapping on this. By tapping on this, you can preview what is rendering. So in the delay frame, so delay frame, the first frame, it is the first frame that needs to be shown when it's getting rendered, and the next frames and the second frame, third frame is the render path. The first frame of this we can assign here, and the second frame, third frame, and so on we can assign here. So we don't need the first frame. That's why we are using the second and third frame like this. So when I convert it to zero, you can see now the camera texture input is going. So the camera texture feed is going on the delay frame. What if when I convert to one? The delay frame texture stored is getting visible. So what we are doing here is the camera texture is going to the mix patch and the output is zero, and then the output is going to the shader render path, and then texture output is going to the delay frame, right? And then we are sending a receiver. Next window. So this is the thing that we are using here and here. So this is, consider this as a sender and this as a receiver. The sender here is 0. We can change the value to 5. You can see in the drop down it has something like locate sender, non-delay frame 0. We have the name here is sender. Say for example, I converted the name to one sender. We need to change the name to here to one center. So the value passing here, the value will be the output here. This is the sender and this is the receiver. So we can delete it. So this is the thing that's getting working here. So the image is getting into here, the delay frame, and the image is we are getting into the receiver. So this is the basic setup of the center and the receiver. And consider this as a loop. The camera texture is passing to the next patch. Where the value is 0, the output is the camera texture. The camera texture is going to the shader render patch, and the output is here is the camera texture. The camera texture is stored in the delay frame, and the delay frame is stored here. Sender it will be getting in the receiver. So when we change the value to here to 1, the camera texture previously stored will get rendered now. So this is how the delay frame sender and the receiver is getting working. And for the split screen method, what we need is we need a 4 rectangle. I'm going to name it as a part 1. This is it. This is it. So now you can see our screen. We need the screen to be separated into 4 parts like this. Plus, for that we need the screen scale size. Okay. Here we have the 4 rectangles. The first part should be the first quadrant, and the second part should be in the second quadrant, and the third part should be in the third quadrant, and the fourth part should be in the fourth quadrant. So we have the 4 parts. So we need to divide this by 4. Let me assign this pattern. I'm going to unpack this. You can see it is showing an error that specifier Z cannot be output with the type of vector 2 because the input here is a vector 2 and here we are having the 3 values x, y, z. So what we need to do is to change the vector 3 to type 2 vector 2. Now I find the width values to our first x value. Now you can see the screen has an equal size. Say for example the part 1 size, part 2, part 3, part 4 size all are equal. So what we need to do is we need to move like this. So in order this to fix correctly, we need to the part 1. Okay, the part 1 is fixing correctly and we need to go to the part 2. Okay, 187.5. You can see the width here is 187.5 and we are moving the x value to 185.5. So when we change the aspect, it gets broken. So we cannot manually hard code here. We need here the value should be 384. You can see now here is the second quarter it gets filled in. But when I resize back to the resolution, the I found out the image is getting out of my custom. So now I need the 187.5. So we can achieve this by packing this value. and then it set it to the position. We don't need a vector 3 and we need a vector 2. Pack stands for packing two of the values, the x and y values to pack. And now we need to do it for the third quarter. So the third quadrant y is in the y value. So I need to assign the y value and then make it as a position. I'm going to move this a little bit up. So our patches looks more in a plain way. And for the fourth quadrant, okay, I just use pen pack. Pack. I need to use the pack. I'm going to assign a material. And I have a camera texture. Now we can see when I change my resolution, it won't get affected. It have the proper size now. The item come back to again, but when you compile to device, it works correctly. So this is how you will be setting into four quadrant and make their position. And then now we need to freeze the frame. So for the freeze the frame in order to work, we can use the screen tab. You can delay a few seconds. In order you want to see the visuals, you need to assign it to a picture. So I just assign it to the background. The restart my screen and will be tapping on my screen. Okay, let me keep up this. The value here is 0. Okay, what what here doing is the value has been set it to a true and then change it to a false. So in order to be have a static value, we need to have the switch back, and we don't need the flip. We need the turn on connection and then get the input. So now when I tap on the screen, you can see the value is 1. It does not change back to 0. You can also see in the screen, you can also see in the screen the frame is getting freeze. So this is the first step. We need to do this for the separate coordinates like the part 2, part 3, part 4. Um, we can do that by one. I'm just deleting this value patch for now. So I'm going to copy this. Let me move a little bit and then it will be easy for me to copy and paste it here. Command C on Mac is Control C on Windows to copy and paste it. I cannot move my screen down. Okay. I need this 3 times, but only we have the 2 patches are here. So I'm just duplicating this 2 times. You can see I cannot go below down. It's stuck it during this pattern. So in order to go down, I'm just creating animation patch and deleting it. So by the way, I can go down and I'm going to paste it one more time. So I cannot go down. I'm creating a simple patch and writing it. So now we have the full setup for our patches. So we need to connect this. So I'm going to make the delay as a 4, 6, right? You can also use the sender, but I'm doing it for the prototype. So I'm just quickly assigning this. So now I'm going to rename the name for the delay class. I'm going to name it as part 2 delay frame, and this to be part 3 delay frame, and this to be part 4 delay frame. So to make a receiver and context here, make a receiver as the same as we doing for the part 1 quadrant. Receiver and context here. Now we need to assign the camera texture for all of this next batch. As I mentioned earlier, you can use the sender and receiver path, or you can drag and drop. So I'm just drag and drop here. So when you use the sender and receiver path, it will be a neat pattern. So as for the prototype path, I'm just connecting this long pattern. So you guys can use the senders and receivers. So I'm going to restart my scene. Okay, the first frame only working. This is because we have not assigned the material texture for the part 2, 3, and 4. So this is the part 2. So the naming is very, very important. So now you can see we have the 3 delay frames, but we don't know which one is our frame. If we start in some of the part, we can name it as a part 3. So we can assign the part 3 texture. So the part 4, part 3, and part 2 can be start the same. Now you can see all of these things keep working. When I tap on the screen, the first 2 seconds, after 2 seconds, the first quadrant is getting freeze, and then after the 2 seconds, it's actually approximately the 4 seconds. The second quadrant is getting freeze, and after 6 seconds, the third quadrant is getting freeze, and after 4 seconds, the fourth quadrant is getting freeze. So this is how we done this. You can see here. After 2 seconds, we are changing the value to alpha to 1. So we are freezing the first quadrant. So after 4 seconds, we are changing the value to 1. We are freezing the second quadrant. And after 6 seconds, we are changing the value to 1. We are freezing the third quadrant. And after 8 seconds, we are changing the value to 1. We are freezing the fourth quadrant. So this is how it keeps working. So, and let me explain you the first frame. Just add a rectangle. Then scene in the path. Just okay, let me import this. I'm going to rename this delay frame. Make it 0. Next, let me count the path and extend it so that it's easy for you guys. You can reduce the share in the path. Texture. we can assign the camera texture. So you guys can now see where the first frame the tap is here to start is getting visible to when I tap on when the value is 1. When I change the value to 0 and change the value to next time to 1, the camera image is getting visible. So this is the first frame picture. It's like the start method that I explained in the scripting section. The first frame, the tap to start picture is visible, and the next time on the second frame, third frame, and so on, the render pass picture is getting visible. So this is for the first frame effect. So I'm just editing this cascaders and building this rectangle too. Let me restart it. So now you can see 2 seconds, 4 seconds, 6 seconds, and 8 seconds. The frame is getting spaced. So this is all for this section. So do you guys having any doubt on this? Okay, I think everyone gets it. And one more thing is we can convert this to a patch asset for a quick working. We can connect these values like this and do as a branch, and we can convert this to a group or patch A, and then you can use convert it to a patch asset. So you can use this patch into the various projects. So you don't want to recreate the patches by repeatedly seeing this. So this is the use of the patches asset. And one more good thing to consider is the block. So it is seen as like the patch, but the block contains a different thing. So that's it. So I will be sharing this section videos in the group as well. So that's all. So okay, guys, I will be ending the section. So thanks for the participation. Thank you. We'll be leaving.